Welcome back to the SSAS and MDX training sessions class 8. So in last session we discussed about how to create a basic cube and how to give the relationships between the dimensions and the measure groups, and what happens if the relationship is not set between a measure group and the dimension. And we also discussed about the partitioning. What is the use of partitions, and how you have to partition to make sure that no record is skipped as part of the processing. Now, in this session, we will be discussing about some interesting topics like the storage modes. What are the different types of storage modes we have in analysis services, OLAP modeling, database modeling, and also we will see a concept called proactive caching if time permits. So first, let's start with the storage modes. We discussed in one of our sessions that how the data will be stored and where the data will be stored when you process the cube. When you do process, the data will be under the data folder of your analysis services installed drive. For example, in this case, I install in Microsoft SQL Server. This is the path in the data, and you see this is our database, and all the data will be stored here in the form of different files. For example, this dimension will have all the storage, and it will have all the keys and the names, all the attributes. You see this is one of the attributes, derived name, and WWI customer ID is one of the attributes. So this is how the data is stored. What is the use of storing the data in the form of files, and why not directly getting the data? Or what are the we call it as storing the data, right? The data is getting stored, or the server is storing the data in the path where the analysis services data folder is pointing to. Now, what are the different types of storage modes that analysis service supports, and how to set that, and at what level we can set the storage mode, and we'll discuss about all these things. Which one is beneficial, which one has more advantages, and which one has less advantages compared to the other storage modes. So let's start with the storage modes. Before starting the storage modes, we'll see one of the students asked a question: what is the 98 here? First we will see this, and then we'll go back to the storage modes. So 98 is nothing but a unique identifier or key. Like for example, if I process the data now, all the files will be reprocessed, and first it will reprocess and then it will delete these files. The old files will be deleted and the new files will be kept. Like for example, let's say I'm processing Wide World Works database. I hope this is my database. This is yep, this is my database. Let me process it, process full, and you can see the changes that's happening here. It adds files, and it adds a unique key here, 104 dot, and once the complete processing is completed, it will remove the old data and it will keep the new one. So during the process, it will have the old data and it will create the new one, and the old one will be deleted once the process is completed. Now you see there is nothing which starts with 98 dot, and hence I can say that the processing is completed. See, process is succeeded. Let me reprocess it. I'm reprocessing it. So it has created 105 dot, and so it will be incrementing. So it will be incrementing for, let's say for example, now it changed from 104 to 105. Now, if I process only one partition, which will not have impact on any other stuff. For example, if I process only employee partition, this guy may take 106. And if I process the whole cube again, whole database again, and this guy may take 107. So it's a unique number to uniquely identify which one is the current and which one is the old one. So that is the purpose of this key, or this integer value before every file in the folder system, in the database folder, data folder. So now I hope that answered your question. Now let's go back to our storage modes. So whatever we have seen now is one kind of storage mode. This is MoreApp storage mode. Okay. If you see the different types of storage modes under the properties of a partition, you have a property called storage mode. Under that you have multi-dimensional OLAP, relational OLAP, hybrid OLAP, and in-memory. There are 4 storage modes in Visual Studio, and this in-memory is for your Power Pivot, your tabular models. This is not for your analysis services. So for analysis services, it basically comes with 3 storage modes. Analysis services OLAP. When I say analysis services, I mean OLAP here. So it comes with 3 storage modes. The first one is Molap, second one is Rolap, and the third one is WholeApp. So Molap is the one that we have seen so far. If I take pen, let me take in. So you have 3 storage modes: Molap, Rolap, and WholeApp. How this makes difference? What is the difference between all these 3, and how to set, and what will happen if you set something else? Okay. So the first thing is Molap. Second thing is Rolap, third thing is WholeApp. So when you select Molap, this is your underlying database, which is your data warehouse. In our case, it is Wide World Works, and this is your analysis service database. Let's say the cube name is ABC or whatever the database name that I've given. So when you select Molap for your partition, what will happen is it will read the data from your data warehouse, and it will copy the data, or it will store the data on analysis services side. When I say analysis services side, it will read the data and it will store in the data folder what you are seeing on my screen, and it will store in the form of files. So this kind of storage mode is called Molap storage mode. So what it will do if you select Molap? The first thing what it will do is it will read the data. And the second step, what it will do is once the data read is completed, it will create aggregations. So aggregations in the sense, if I have 10 attributes, it will create aggregations. It will create high-level aggregated data so that the querying will be faster. So the leaf level data is nothing but if you query 2 tables, it's a root level data. It's a leaf level data. Every row, if you join 2 tables, this is your dimension table and this is your measure group table. If you join these 2, plain join, so this is nothing but leaf level data. You will get every row for every record, right, in this combination. When you say, that is what it happens as part of this. It reads the root level data and it stores in your analysis services, and on top of it, it creates aggregation and then indexes to improve the performance. What do you mean by aggregation? This is, let's say when you join 2 tables, you're getting 50 million records, the dimension table and the fact table. If you group by year, and if you have 10 years of data, how many records you will get? You'll get 10 records. 1 record for each year, because 2010, what is the sum of sales? 2011, what is the sum of sales? That's how the aggregated data is nothing but when you apply some aggregate functions, like sum or count or max or min, something like that in your SQL, the count you have to go for group by, and the number of rows will be drastically reduced, and all the calculations, whatever the aggregate function that you have specified, like in our case, let's say it is sum, then it will calculate the sum, and that is the aggregated data. What analysis services Molap storage engine will do is it reads the data as is, and then it creates the aggregations. And on top of this whole stuff, it creates indexes. So indexes is purely for improving the performance. So for a quick example, let me take SQL Server, and let me connect to database engine, and let these drawings be as is. I don't want to draw it again. So if you go to new query, when I say reading the data, the particular step here, the error mark I have given here, that means select start from fact dot save. So reading this data as is nothing but the first step of MoreApp processing. Okay. Now, creating aggregations is it takes the attributes and it takes the fact data and it will try to create aggregations. For example, select start from dimension dot, let's say, city. So you'll have city information here. Now let's say this is A, inner join fact dot sale. I'll name it as B on A dot city key is equal to B dot city key. So this is nothing but free data. The data as is, reading the data from your source. How many records you're getting? How many records you will get? Let's see, it's still reading the data. You get 22, 82, 65 records. Now, analysis services create aggregations on top of it. Let's see a sample. Let's say I have an attribute called region. So how the aggregations will be, and my measure is sale amount or tax amount, and the aggregate function that I've used is sum. So what it will do is it will select region, comma, sum of tax amount, I think, as T amount, group by. So this is the aggregation for the attribute region. So how many records you're getting? You're getting only one record. So instead of keeping the data only the raw data, it will also create the aggregations. Now, when the MDX query or when user try to query the cube, and if we select region and if we select the tax amount, it will get the output from here instead of going through all the records. So the aggregations, pre-calculated or pre-generated aggregations, pre-executed aggregations will make the querying faster. That is the beauty of MoreApp. So the querying will be faster because it has pre-calculated aggregations or pre-executed aggregation. Let's say I have a city, and if I create an attribute city in my cube, and then it will create an aggregation and it will store the data. It will have only 655 records. So whenever user selected city and the tax amount in the cube browser, it will go through the 655 records instead of 220,000 records. So which will be faster? Obviously, this will be faster because this data is already calculated and stored in the form of aggregations in analysis services when you select Molap storage mode. Now that is the first storage mode. What is, we will talk about the advantages and disadvantages later in this session. What is rollup storage mode? Rollup storage mode means relational OLAP. So when you select a particular, let's say this particular partition has rollup storage mode, and if you try to process it, what will happen is the data will be here only. It won't read any data to the analysis services. It will keep the data there. It won't touch the data, and it will create aggregations and store it in the form of materialized views here. So the views and all will be on the relational database side. So nothing will be on your analysis services side. So you don't need extra storage for this. Rollup is beneficial to reduce the processing. We'll talk about the advantages. So when you say rollup, the data as well as the aggregations and the indexes will be on the relational side. Relational side. When you say relational side, whatever the underlying database or underlying data warehouse on which you're building the cube, it will store everything over there. So that is rollup storage mode. And the third one is hybrid. Hybrid storage mode or hybrid OLAP means it's a mixture of MoreApp and rollup. So when you talk about the storage mode, you talk about the data and aggregations, right? Data will be here for the whole app, and the aggregations will be created on analysis services if there are any. So in short, MoreApp, both the data and the aggregations will be on the analysis service side. For rollup, both the data and aggregations will be on the relational side, which means the underlying database relational side. And for a whole app, the aggregations will be on analysis service side and data will be on your relational side. So these are the three storage modes. Now, before going to discuss about the advantages and disadvantages of each storage mode, we will see how the data or how the files will be changed when you select different storage modes. So first, let's go with MoreApp. You have seen the MoreApp storage mode, right? Let's see an example. Let me clear these drawings. Now, everything is set to MoreApp. And if I process the cube, Where is that? It's here. So let me process it. And it's completed almost. And if you go to your partitions under cube, you have sales partition, and each partition will have all the data related files. And this is what which talks about the fact data, and all the key mappings and all the stuff will be here. So the data file is always the highest one because it will have all the raw data. If you have millions of data, this file will be growing like anything. And similarly, you have another partition. So every partition will have its own data file, and there may be partitions where there is no records at all, so the data file size will be very less for that scenario. Let's see if there are anything where the files are very less. So where the number of records are less in the partition. There is no such case. So it's always 1072 KB here at least, or at least 500 KB. Now this is the data file, and these are the helping files or the other files which has all the mapping information and particularly key mapping information and information about this partition. That is very important too. Now let's try to give relational OLAP as the storage, set relational OLAP as the storage mode, and see what's gonna happen here. So for that, I have to change it. So to change this one, I can select any one partition. For example, I'm selecting 2013 and below the partition. Okay, and I'm gonna change the storage mode to rollup. And let me deploy it. I need to deploy it, and I can process it too. So remember, I set it to one of the partitions. I think the partition key is 0, or what is the ID? It's a sales data. So the folders will be created with the name of the ID, with the ID whatever we have. If you see here, for this particular partition, the ID is sales data and the name is sales data 2013 and below. So let's look for the folder sales data. If you go to the sales data, there is nothing left except info.33.xml. So rest of the files are deleted because the storage mode is set to rollup. That means all the aggregations and all the data related to this will be on the relational side if there are any aggregations and the records. Now, if you set the whole app, it will be the same, almost the same. The reason is there will be no aggregations created based on the data because we have only 200,000 records, and it doesn't require, analysis does not require any aggregations for it. So you will see a similar file when you select whole app. Let me show you that. The reason is if there are any aggregations, if the data is huge, then it will create aggregations. Analysis services has its own calculations to create the aggregations. It won't create aggregations for all the partitions. If the data is very less, then it won't create the aggregations. If the data is like in millions, then it will create the aggregations. Now, I selected one of the partition as whole app storage mode, which means the data should be in relational and the aggregation should be on your analysis service side. And I will not see any aggregations as it doesn't require any. So new file created, old file deleted, and it has only info.xml. So though there are no files here related to this partition, you can still browse it because it's a whole app storage mode what you have set. If I select new query, I can see that database, and I can see everything, and I can see the measure groups. When I drag and drop, it gives me all the data. Now, with whatever we have discussed so far, you can easily say one of the advantage of your rollup and whole app compared to Molap. What is the advantage that you can think of? The storage. If you see, this is your Molap, and this is your rollup, and this is your whole app. So which takes more space, more storage? This takes more storage because it reads all the data, and it reads. If you just simply see the folder size of a Molap partition or whole app and whole app partition, if you see the properties of it, it will be like 822 bytes, right? And if you see any other thing, it will be definitely bigger than. It's a 725 KB, right? It's bigger than the other one because it is reading the data. So remember always the storage for the Molap is greater than or equal to Rolap and Holap. It will be definitely greater than, and it will be huge difference, like 10 kb to 10 GB, even more than that. Sometimes if you have a lot of records in your fact table, then the storage will be huge on your analysis service side. So Molap, the one disadvantage is storage. Rolap advantage is storage. OLAP advantage is storage. So this is advantage in these two because it won't take much storage, and it is disadvantage in your MoreApp. Now, with whatever we have seen so far, we can also see one more difference: the performance. The performance will be obviously better in MoreApp. Performance, if you see, Molap is far better than Rolap and Holap. The reason is, if you write an MDX query and if you execute it, if it is a Molap storage mode, it will come here and it will read the files here, which is compressed and stored in the best way possible. So it will read the data and it will publish the data. And also all the aggregations will be here. On the other case, if you write an MDX query on a Rolap storage mode partition, then it will go to your underlying SQL database, and it is almost like reading from your relational database. One of the major important point for implementing Cube on top of a relational database is to improve the performance. So if you have to go back to your relational database for getting the data, then the performance will be poor here. So performance will be poor, and performance will be poor for detailed data but good for aggregated data because aggregations will be stored on your analysis services. So, and the third thing, processing time. So as it has to read MoreApp has to read when I say processing, the data and the aggregations. So for MoreApp, both will be on your analysis services. So it has to read every record from your relational database to store in your analysis service side. So the processing time will take more. It will be very much high compared to relational and hybrid. So if you select relational, it will be processed just like that in less than a minute. If you take the processing time for the same cube, which has like 100 million records in your fact table, by setting the Molap storage mode for the partitions, it will take at least like 20 minutes to 30 minutes, depending on how narrow or how wide your fact table is. Wide in the sense how many columns you are pulling in and how many dimensions you have on how many aggregations it has to create. And for hybrid, the processing will be comparatively better than Molap, but not better, I mean worse than Rolap, but it is in between. Okay, so if you see processing, this is a disadvantage. Molap has disadvantage, and performance it has advantage, and storage it has disadvantage. Whatever it has advantage here is disadvantage here. So it's a quite opposite, right? The performance is good here, performance is bad here. Storage is bad here, storage is good here. Processing is bad here, so processing is good here. So we have seen three things, three differences, and what else we have? Another major disadvantage is with the Molap storage engine is Molap is always outdated data. If you process your cube now, okay, this is your relational database and this is your cube database. When you select process now, okay, it reads data from here and stores it here. The next minute, if there is a new record inserted here, that will not be available here. You have to process it to get the data, right? So it is not real time. It is always outdated. If I process now, next minute it is outdated. If I process now and if I see after 10 years, it will have the same data, whatever that was available when I processed the cube. So the major disadvantage that people don't like in Molap is it's always outdated. That is the advantage on relational. The reason is relational, if I execute a query, the query will be sent to your data warehouse. Whatever the number of records I insert and whenever I insert the data, it will be always available in the result set because it gets the data directly from your relational database. It won't store anything in your analysis service side. So That's the advantage. Even here, it will be real time. It will be real time for the leaf level data in the whole app. So if you see more for MoreApp, it's a lot of disadvantages compared to the advantages. See, the storage is a disadvantage, processing is a disadvantage, performance is advantage, and real time. It's not real time, it's outdated. So it's a disadvantage. But if you see the percentage wise, if you ask me, at least 90% will be using this. 9.9999% will be using this. 0.00001% will be using this. The number of users who use this is very high compared to Rollup, and there is no good Rollup support from Microsoft because not much user base. Not many users go for Rollup storage mode, but I know few users who use this Rollup storage mode to get that real-time behavior. Okay. Okay. Now let's see something that improves the performance, query performance. I mentioned in last session that partitions not only improve the processing time because it reads the data in parallel, it also improves the querying performance. When you write the MDX query, it improves the performance. I'll tell you the reason. I'll show you one example here. Let's say you have 100 partitions like this created. Okay. And if you go to the partition which has Molap storage mode, you will see this info file for every storage mode. But for Molap, you will have more information under this info.xml. So the beauty about Molap is while processing, it also gets the distinct keys of each attribute that is available. For example, if you see map data set is very important part of it. If you go for other, let's say whole app, let me go to whole app, and if you go to this, I don't have much about the map data set, but here in the other case, the map data set has a huge set of information. Under that, map data indices is very important thing. So map data indices is not available for the other stuff. Here, see, it's empty. So what map data indices? While when you set it to Molap and when you read while reading the data, what it will do is it will take each and every attribute that is related to this particular partition. When I say a particular partition, so this partition belongs to this measure group sales data. So sales data measure group has relationship to these three. Similarly, if it is processing for this particular partition employee, then it will go and it will get whatever the dimension that it has related to. So it will get all the attributes from the employee while processing this. Similarly, while processing sales data, it get all the attributes from here. And for the data that it read into that particular partition, what is the maximum key and minimum key for each attribute? So in short, let's say, let's take an example here. For example, employee. Okay. So what all employees has sales for the partition data that is reading into this partition. Let's say this is my partition. This partition is reading 2013 data. So the 2013 data will have a definite set of employees. So if you see minimum is 3, maximum is 20. That means if I have 20 or 40, 50 employees, let's say. So the minimum employee ID for the 2013 data is 3 and maximum employee ID is 20. Let's say this is 20. So for 2013 partition data, the employee keys will be ranging from between these only. You don't need to check these two and you don't need to check this. The outer bound you don't need to check because it is giving a hint to the analysis services while processing. It is taking the information and it is storing the information like, okay, this has the data belongs to the employees starting from here to here. So it gives a hint. Let's say you have 100,000 employees. Out of that, you have only 20 employees worked in 2013. It will have only that 20, and these 20 attribute members will be looked into the partition. Thus, it gives a hint, and it's kind of applying extra filter. and less data will be read and less data will be analyzed for all the calculations and all. This improves a lot of performance. And let me go down, scroll down a little bit. For example, if you see here, the customer key or the customer starting minimum customer is 2, maximum is 404. Okay, and similarly you have a bill to customer. If you have 10 customers in this, 10 member values in this one, the minimum is 2, maximum is 4. It will look for only those bill to customers who are between 2 and 4, and then it processes this data. So first of all, the partition itself, it will be less. And also if you apply any filter like give me only a customer XYZ in your filters, so it will come here into the info file and it will check if this customer falls into this range, yes or no. Let's say yes, then it will look into this partition, and it will go to the next partition whether this customer falls into this or no, then it skip that partition. So that's a beautiful advantage. Let's say you have 20 partitions and you have 10 years of data, and this year is 2013. And in your filter condition, if you specify give me data for the year 2013, so it will come to the XML file of this particular partition and it will see what is the date range for this, for the year range. If it gives 2013, it will get the data from here. Then it will go here. It will see the XML file. XML file reading is just like a flash. It will read that and it will see whether the 2013 falls into the minimum and the maximum set here. It will not fall. So it will skip this. It will skip this. It will skip this. It will skip this. So what it will do is it will read only one partition data instead of 20 partitions data. If you read all the 20 partitions data to find out, reading all the 20 partitions data and then applying filter is slow in performance compared to apply the filter and then read the data from the partition that has the data for the year that you are looking for or the filter criteria that you are looking for. Let's say you selected an employee Rupesh, and if you look for the data, first it will come here the employee name and it will see whether Rupesh falls in between this. If it is no, then it will skip this. It won't read the partition at all. So that saves a lot of time in MDX processing, MDX query processing. Now, when you select MoreApp storage mode, this particular info file will capture all the information, which improves your performance. If this is not created, then you can give your slicer hints to improve the performance. Let me show you the slicer hints. For example, if you go to the partitions, cube structure, let's go to the partitions. Here, if I go to the properties, there is a slice. Here you can specify the tuple that defines the slice of data contained within this partition. So after the partition is created, and if you know that this particular partition has the data for the year 2013, and if you have a date dimension, you can drag that. Let's say this is year, and if you select that year and you can drag it here. So this gives analysis services a hint and information that this particular partition has this information, has this particular year information. I don't have a date here. So let's say, for example, if this particular partition has only data that belongs to the employee, this guy, and if I save it, then, or you can have multiple employees too. If you know all the employees that has data in this partition, you can specify that. This is an extra validation or extra hint to the analysis services that, okay, in this partition, you will find this employee information. So jump into this if the filter condition is having this particular employee name. So this slice gives you an option and a hint to the analysis services, which uses to improve the performance of your MDX querying. Even if you don't give slice and if you select MoreApp storage mode, you are all good. It creates a lot of hints by itself, like what is the minimum key and the maximum key. This is the best data. See, for example, sales data, right? And for the sales data, I created a dimension, if you remember, for the description attribute. Okay, this description attribute has like 22,000 records, right? So for this particular partition, it has the records between 60,970 to 126,910. Only for these set of members that fall into these indexes, it goes to this partition. If you query anything else, then it won't go to this particular partition. Now, so any questions here? I tried to get this index value, but I don't see any query. There was a query. I used the query once. I'll try to find out. If I find it out, then I'll share it with you guys. So my intention is to show or generate what is the index value of this. Let's say this is 1, 2, 3, 4, 5, and so on. It is saying that from 2 to 228, it has data. The dimension members or the attribute members 2 to 228, with the index 2 to 228 has data in this partition. So I thought of showing what is 2 and what is 228 and what is the range that does not have any data in this particular partition. So this is about the different storage modes, and you can set the storage modes using the property here. And you can set the storage modes at the dimension level or at the queue partitions level. Okay, now let's see. There is an option called, the major disadvantage for MoreApp compared to RollApp is real time. RollApp is real time, whereas MoreApp is always outdated. So to overcome this, they introduced a concept or a property called proactive caching. Proactive caching means, as the name says, it's proactively cache the data and it will use the data in your analysis services. Let's say, for example, you see here, this partition is OLAP, this is Molap. Let me set it to Molap. Let me set everything to Molap, okay? And now, if you see a property here with the name proactive caching, it specifies the proactive caching settings for the partition. If you select this, by default, analysis services has few proactive caching storage settings or partition storage settings. The MoreApp, which means 100% MoreApp, all the data will be here. You have to process to get the fresh data. If you select scheduled MoreApp, which means processing is automatically performed every 24 hours. You don't need to process manually. This partition will be automatically processed every 24 hours. Okay. And automatic MoreApp, you can set anything. Okay. So if you set automatic MoreApp, processing is performed automatically with no restriction on latency. If any data comes, it automatically processes and it caches the data and it will store the data. So when I say cache the data, let's say this is your analysis service storage and it will maintain a cache. It will store all the new records into here. And when you run an MDX query on your analysis service MoreApp storage, it will return the result and it will execute the same query here. It will merge the data and the data will be returned. So it is almost like real time. It gets your analysis service, whatever you have processed, it will get the data from here. And whatever it is here, like whatever it is cached, it is processed after the last actual process was done. It will be cached here and it will merge and it will show everything in the output. Now let's go to the next one. Medium latency is, it will be like 4 hours. It wait for 4 hours and then it will get it. And similarly, low latency with a targeted latency of 30 minutes. And you can see the properties here, what it means. We'll discuss about this. So the properties will be changing based on the value that you set there. This is medium latency, this is low latency, which means every 30 minutes it will process. And real-time OLAP is nothing but it's a OLAP storage mode. All the queries reflect the current state of the data. Will be because the queries will be sent to your OLAP storage mode. And finally, real-time rollup. So between MoreApp to rollup, all these fall. All these different proactive caching techniques fall. So rollup means directly the queries. All the queries reflect the current state of the data. Real-time OLAP means it's the same. but only the aggregations will be stored on the multi-dimensional format that may be little slow in performance. Okay, and if you select low latency for every 30 minutes, the server will listen to the notification when data changes. Process is performed automatically with a target latency of 30 minutes. And medium, it's 4 hours. Automatic, it's real time with no restriction on latency. And schedule is for every 24 hours. And Molap, it's manually. You have to perform it manually. So these are the proactive caching techniques. If you use any one of these options like medium latency or automatic latency or low latency, then it gives you near real time for your Molap, because it will have your processing data here. Okay, this data will be here and all the new records will be cached. It will listen to the notifications. A notification can be sent from your SQL server or from the third-party application saying that, oh, there are new records, go and fetch that. Okay, so once it listens to the notification, then it will go and get the data and store it in the cache. All the new records will be stored in the cache. And when MDX query is triggered, it will get from your analysis services database as well as your cache, and it will merge it. Okay. Now, if you don't want to set this manually, then go with one of these options. Like if you want it to be automatic, you set this and select OK. And you have to select some query for this. Okay, I'll show you that. And if it is scheduled OLAP, it's 24 hours, you can set it. If it is automatic, you have to change some properties here and you can select OK. Similarly for medium latency and low latency. Or you can directly set it, custom settings. You can select all by yourself. The first thing you have to set is this, the storage mode is MoreApp, and I want to enable proactive caching. So when I enable proactive caching, it has different options here. Cache settings, update the cache when data changes, drop outdated cache, update the cache periodically. So what will happen is, when you select this, update the cache when data changes, that means it looks for the silence interval. First, it will listen to the notification. Let me draw something. So this is your analysis services which you processed, and this is your cache, temporary cache, for example, and this is your SQL server. Let's say this is sending notification to your analysis service project. So once you get this, once it hears this notification, it is saying that there are new records inserted into your data warehouse. Okay, then it will wait for 10 seconds. And why it wait for 10 seconds? To listen if there are more records inserted in 10 seconds. If there are no records inserted in the next 10 seconds, it will start reading the data and store it in the cache. So at 10 p.m., 10 seconds, it will first listen and wait up to 20 seconds. If it listens again, saying that new records, few more records inserted, then it will wait for 10 more seconds. And if it listens again, okay, 2 more records inserted, it will wait for 10 more seconds. And it will continue to wait until it stops listening to any notification saying that the new data is inserted. So it is giving some bandwidth, some time to the analysis server. Analysis server is giving some time so that the data will stop loading at the source and then it will start reading. The reason is, if the data is continuously loading for every 5 seconds, it doesn't make sense to process the data every 5 seconds. So it waits for 10 seconds, wait for 10, 10, 10, 10, and it stops listening any notification saying that it's not, no data is loaded, no new records loaded. Then it will start processing and it will read the data and it will put it in the cache. And this silence override interval means it will continue to wait for 10 seconds, 10 seconds, 10 seconds, 10 seconds. And if it cross like 10 minutes for this, it wait a max of 10 minutes. Then it will go and read the data. Even though it listens some notification saying that new records again inserted, it won't wait after 10 minutes. 10 minutes is the silence override interval. Don't be silent after 10 minutes, after continuous 10 minutes wait. If you are still getting new records continuously for every 5 seconds, not a problem, go on process the data. I can't have a lag of more than 10 minutes. Let's say my record inserted now. After 5 minutes, in 2 more records. After 5 minutes, 5 seconds, 2 more, 2 more, 2 more, 2 more, 2 more. So after 10 minutes, what will happen is this is 10 minutes old data yet to be processed into your cube, right? So it gives this override interval tells the analysis services you waited enough. The data is continuously coming into your data warehouse. So don't wait for it. Go and read the data, whatever you have. And the next set of data we can read later because this is already too late. The first record that is not yet processed into the analysis services cache is 10 minutes old, and I can't wait more than that. So process it. Or you can change this interval to, let's say, I don't want to wait for more than 1 minute. So every 1 minute it processes the cache. Every 1 minute it processes the cache. Or you can select 15 minutes. Okay, I'm fine with 15 minutes. Every 15 minutes, look for data coming for every 10 seconds. Let's say you got 10 records in the first 10 seconds and next 10 seconds there is no new data in your data warehouse. It immediately pulls. It will be silenced only for 10 seconds. And if it did not listen anything in the 10 seconds, then it will immediately pull the data. Now, if you see drop out outdated caching, so let's say you can give some minutes, like after every 30 minutes, clear all the cache and create a fresh cache. So you are specifying, okay, after every 30 minutes, clear the cache and create a fresh cache. So when you when you clear the cache, these queries will be sent to your relational database for that period of time. Okay, so if you go back to the stuff and if you select standard setting, schedule, I think automated Molap with latency, if you select the options, there is no drop outdated, it will be always up to date. If you select medium latency, it says 4 hours. So processing is performed automatically with the target latency of 4 hours, which means after 4 hours it will clear and it will process the data and it will get the data into your analysis services. Whenever it drops the cache, it reads the data into your analysis services and it will start a fresh thing again. Because the cache should not be building. If the cache, let's say you are getting more and more records, in 4 hours you may get huge data. You don't want to keep everything in cache. In that case, so drop outdated cache here and get the data into your analysis services. You see here processing is performed automatically with a target latency of 4 hours. After 4 hours, processing will be automatically performed. If you want to process automatically after 30 minutes, you can set it to low latency, or as I mentioned, you can go to the options directly and select it here. Instead of 30 minutes, I mean, my job is scheduled to process every night. So I can ignore about this. Every 10 seconds with the silence override interval, it will read the data and it will store in the cache until the next complete data load. Or if I don't want to keep that long, I can set it to 4 hours or something like that. Every 4 hours, it will clear the cache and reads the data into your analysis services. And update the cache periodically. One second. So if you want to update the cache periodically, rebuild interval, I mean, I've never used this property. I'm trying to find out. Let me go here. I have to see this. I've never used this. The force rebuild interval valid is not valid. Oh, force rebuild interval means like if you drop this cache, like for example, so you are asking the server, you're forcing the server to rebuild the analysis services partition. You're forcing it, and it should be like it says almost like drop outdated cache. If you specify it like 4 hours, and if you force it to rebuild it after 4 hours, then it will go and rebuild the whole partition for after 4 hours. So this is more like sending the hint to the analysis services to process it, rebuild the whole analysis services, and bring online immediately means if you have a data in your real time, then you are asking the server to bring it online immediately. Don't wait for it. In this case, if you check this, what will happen is if this is going on continuously, like let's say this slice interval is going for 10 seconds and slice over, 1 second, something is missed. I think I screwed, oops, I selected the wrong one. Okay, my bad. I selected the wrong one. So if you bring online immediately, let's say this is continuously going for 10 seconds, what this option will do is it will send the query to relational database to get the data while it's building the cache. It won't wait. So you have so many options in one page to set to achieve near real time. It's not 100% real time. Here, if you see in this case, it has 10 minutes, and here for few data, it goes to the relational database. So this is all not 100% real time, but very close to the real time. And enable rollup aggregations means for all the new data, it will create the aggregations on the rollup side. I told you the data and the aggregations for the MoreApp will be created on the analysis service side. So meanwhile, when the data is reading into the cache where it has to create the aggregations, it is saying that create the aggregations on the analysis services side. So if you set these properties, the thing that, I mean, if you set these two, these are good to go for your real time, pseudo real time. It's not exact real time. When you select MoreApp, when you select the silence interval for 10 seconds and silence override interval to 10 minutes, you can try it out. What you can do is you need to create a cube and set this page as is, and you can also drop this with 4 hours latency. Okay, and if you leave the cube without processing, first time process, and if you leave it, and if you insert a record into your cube, into your data warehouse database fact table, then you can see that data in your cube browsing. So automatically, the system in the background will go and read the data and loads into your cache, and it will be what you call it will be merging with your MDX result sets. Now the key thing here is the notifications. You have to specify how to track it. For example, specify tracking tables. Go and track this particular table, and SQL Server will take care of it. Let's say this is a SQL Server, the good option that we have in your SQL Server. If you select this table, so now we can't state on alter trace. Okay, so what will happen is it will go on track this table. So this table will be tracked, and any changes will be notified. If there are any changes to this table, then it will say analysis services, there is a change, that record is modified or inserted into this particular table. Then analysis services will go on, get the record from there and update the cache. So this is called, when I say notifications, this is how the notifications will be. And another option is client initiated. So client initiated is like if you have an XML command in analysis services, any client like analysis services, then you can use the help of analysis services to integration services to notify. And there is a command called analysis services DDL task, which says that, okay, there is a new records, and go and do process add or add to the particular partition. So that's how you can hear this. And to be honest, you'll not be using that. And if you want, I can show you an example how analysis integration services is used for adding the incremental records into the cubes. And schedule pooling is like enable incremental updates. You can have a pooling query and processing query. Pooling query is basically says like what is the maximum record in the sales table. Like for example, select star from fact.sale. So this is our fact table, right? If I execute it, it is giving me whatever the data that is available in my sales table. And sale key, let's say this is your primary key or automatically generating key. So what you will be doing here as part of this is you'll be getting the max of key. So what is loaded so far, and Let me see an example for that. So what you will be doing here is you will be specifying a pooling query. Pooling query is nothing but what is the parameter that I can get into. I can get the value from, like, let's say for example, date. What is the max date, or is processed per flag. Let's say your database has a flag called is processed, which means that is processed into your cube, and you can get only those IDs which are not processed, and you can use it in the processing query. So once you give the pooling query, you will get the processing query. And here you will be giving select star from the fact data where that ID is greater than this and less than that, something like that. So if you want an example, let me try to get an example for this. Let me show you that. If you have a date field, then it'll be easy to show that. Select star from fact.sale. We have these fields. This table is a sheet table, as I said. So for using this option, you need to have a date. For example, let's say, let me take an Excel, and let me show you your fact data, ID, tax, and sales. So one, let's say $10, sales is $20, this is $30, this is $15, and this is 2. And the same data is repeated. For example, let me do it an increment, and let me have it like this, and let me have it this. So we need to have a new column here. Let's say date, or loaded date, or date loaded. Okay, so what this will be doing is whatever the get latest, whatever the get date, it will be loaded here. Let's say for example, this record inserted today. Okay, when I say this record inserted today, that means what it will be, 1/17/2018. What is the time? Time may be 9/17, right? Now the same time all these records are loaded. Okay, I'll use it as copy cells now, and these records are not inserted by the time. So when you process the cube, what will happen? These 5 records will be loaded into your analysis services, correct? Now after 10 seconds or after 1 minute, I loaded the remaining data, and here it will be the next minute, right? Or next day, or how can I explain that? I'm not getting a best example here because this is not used. So let's say this is inserted at 9/18. Okay, and these set of records are inserted at 9/18. So if you see here, copy cells, these are the new records. These are processed already there in our cube. When I trigger the process, it has read everything. So what it will do is the pooling query, what it will do is it will try to get the maximum of this date. What is the maximum of this date? This is the maximum of this date, right? And then it will have another query called processing query. And this processing query, what it will do is it will have the loaded date loaded greater than or equal to this, and less than or maybe the date equal to this. So what will happen is these records will be pulled. These records will be pulled into the system, into the cache, and these records will be merged with this. So when you do maximum dates on the analysis services, it gives you this date. Okay, and anything greater than that, it will get all these records. So this is how they write a processing query and a pooling query just to find out if there are any new records. This is for a schedule pulling. This is if you want to do all by yourself. If you want to take the help of SQL, like this works fine for other databases like Oracle and all. If you want to take the help of SQL, you can specify what is your table that needs to be tracked. If you specify the table, this will be tracked for and it will be looked for any notifications. And if you select this will be set with medium latency and Molap. So this is how you can enable proactive caching. So the key thing here is, if you go back here, the key thing here is setting what is the slice interval, how frequently you want to listen for a notification, and what is the override interval. And if you want to drop out and process everything into your queue or update the cache periodically, you can select this. And notification part for us for SQL Server databases, you have to use this. And if you want to take the help of third-party clients, like for example integration services, which gives you an XMLA command to tell if there are any new records or not. So you can use this client initiated, or you can use schedule pooling if your database is properly designed. And if you see an example, first time I'm seeing this example too, you see he has written some queries here to get the maximum for each stuff. Select max of loaded date that comes from your SQL, and he's looking for loaded date greater than and less than or equal to, which means it's equal to. It's almost same like equal to, right? So you have to write your what you call the pooling query and the processing query. But to be honest, I've never used this pooling query and processing query. Or there may be other ways of doing it too. The other way may be like you can have an ID, automated generated ID 1, 2, 3, 4, 5, 6, and so on. You can get the max ID that has been loaded as part of your pooling query, and you can get the processing query as get everything where ID greater than the maximum ID. So the maximum ID will be assigned from this output to this question mark automatically, and it will pull only the newly added records. Okay, or you can use the last modified ID when it was last modified. If you maintain a different ID just like a date, you can use that in your pooling query as well as processing query. This is a little tricky, but I would say give a try and you can see the data coming into your queue. Particularly the good example or the good thing that you can try or easy thing to try out here is, let's say customer dimension will have limited, and you can set the proactive caching here too. So let's say you have 100 attributes now, 100 rows in your dimension table, and if you add a new row and if you select this automated pooling and set the same options here, let's say bring online immediately and set the notifications to select the table customer, and it will do it for you. So just set the 10 seconds and 10 minutes and try to insert couple of records into your customer dimension table and see the new data coming into your cube automatically when you deploy it with automatic Molap proactive caching option. So any questions here, guys? Okay, cool. That's it for today's session, and we will meet again tomorrow, and I'll try to come up with an example, or if you try at home, that's a good exercise, and I'll show you one or two examples for the proactive caching. Even I can do one thing now. I can set it now. I set this to automatic Molap, and the options are set to for every 10 seconds go and look it, and the notification table is customer, and I can deploy it, and I will not process the cube. I will just I'll process the queue once after the changes are made. Automated caching, right? Sorry, automated proactive caching is set. Now, tomorrow when the class starts, I will simply insert a couple of records and I'll show it to you how these records are coming into a cube without processing the data for the customer dimension. So this is all set. If I add it now, by tomorrow morning, even before I process it, you can see the data. We'll see that tomorrow. Thank you so much for joining, and we'll meet again tomorrow.